Lesson 11, volcanic hazards. This is the follow-up to the theoretical aspect on volcanoes. This is actually 2 case studies, but you only have to learn 1 case study for the exam, but I'm doing 2. For those of you who are looking to really push the boundaries, I think knowing more than 1 case study of each of the hazards is a wise thing. But on here, I've chosen 2 volcanoes from the Philippines. One is more basic in its information, so you might decide that that level of volume of information is right for you. Some of you might want to go the extra mile and use something maybe that's a little bit more, has a modern context and it has more depth. So in the previous lesson, I covered the causes of volcanoes, the location of volcanoes, the types, the classification, and the primary and secondary hazards, alluded to the different sorts of impacts, where you see primary, secondary, environmental, social, economic, political. There's an acronym for that, SEEP, S-E-E-P, that's just rearranging those words, social, economic, environmental, political. It's a good one to remember. I've discussed this. The one thing that I haven't done, and I'll do this in the next lesson, is look at this side of it. How do we cope, prepare, mitigate, etc. with a volcanic hazard or volcano erupting? Then you have to look at where it says recent volcanic event. That's your case study. And with all the hazards in this unit, sort of follows this format. You've really simplified. You look at the causes of it, you look at the impacts of it, and you look at the response, the management towards it. There's an underlying theme, and it backs up the key words that are referred to in the earlier part of the units, like words like mitigation, fatalism, prevention, etc. So there's a lot of overlap here. So remember, when you're doing this, if there's another case study, remember you're reinforcing the conceptual geography that you're learning, the theoretical geography that you're learning in the earlier part of the unit. That's a good thing. And anyway, let's move on. This is an actual picture. It looks more like an atomic bomb going off, I think. It's just crazy. The one that I'm using is 1991. So theoretically speaking, you might argue that's kind of out of date. Usually around about 20 years for a recent example. But I've never been told as an examiner not to credit something, and I still think this particular one, I'll show you in a second, is still a really relevant one because it had a global impact, had such a big impact, and that is Mount Pinatubo. So Mount Pinatubo erupted in 1991, had both local, regional and global impacts. That's why I think it's a particularly good one. It's an active volcano. It will erupt again in the future at some point and has since 1991. Mount Pinatubo is found in the archipelago islands of the Philippines. It's like 7,000 islands. And we're in the West Pacific, this area here where I'm moving. You can't see, actually. Let me just get the button back on again. There we go. There you can see just kind of in that area there. I'm putting it up a little bit. And there you can see, this does no justice to just how many islands there actually are. The Philippines has something like 28 volcanoes. I'll confirm that a little bit more in the next slide. I think the country with the most active volcanoes is the United States, mostly in Hawaii. Japan's another country with lots of volcanoes. And Indonesia, they dominate the 500 or so 500 active volcanoes that we know of. The reason why I'm using Mount Pinatubo and a later case study is that many of you, I certainly do, there's a multi-hazardous environment as a big case study, and what I'm trying to do is overlap some of that, so you're not having to learn completely new examples of hazards. So the volcano that you look here, you use as a case study for the volcano, but you also use it for the multi-hazardous environment as well. So there's overlap, and I do that with one of the storms as well, the tropical storms. So here's Mount Pinatubo erupting. I'm not sure this is the 91, but it's just on a repeat animation slide here. And it's a stratovolcano, composite volcano. Next picture, it's a still, you really see it erupting. I always think, and I'm still not convinced, this does look a bit photoshopped. This picture's quite old now, but it just looks like if you saw that, you'd be going, "Oh boy." So it really looks like something bad's happened. And if you remember, like that's the velocity. That must be over 1,000 kilometers per hour. Lots of pyroclastic material, ash impacting the weather, mudslides, mud flows, all those sorts of things. They knew it was going to erupt. And you can just see some sort of clips that I've just put together on this slide here. I mean, and you can see it's not just one event, so you get like a series of eruptions. They did know about this in advance. The Philippines, although I would probably a middle-income country, maybe an NEE, newly emerging economy, back in '91, it's obviously on that progress to there. So it has lots of characteristics of the developing world, hence like fatalistic response, quite a lot of poverty there. But it also has the Americans there. They have a Air Force base there, the Navy operate in that area. They have troops stationed there. So they have a lot of high tech stuff and ability to maneuver things. So they knew this was going to erupt and they did take a lot of early action. So a couple of things. So if you're going into an essay and you have to talk about your multi-hazardous environment or a volcano, it is important to remember some of the background to this. So the physical causes, natural causes of the eruption, plus also earthquakes as well, is that it lies on this plate boundary. There's some smaller plates there as well. It's a destructive boundary where one plate goes underneath the other, the denser oceanic plate usually under the continental plate. I know it's a bit more complex with the plate boundaries here, so there might be ocean going under ocean. It's a subduction zone, there's that word again that you're using, and I've got 25 active volcanoes here, so I may have slightly contradicted what I said a little bit earlier on. That's not something to worry about if you're slightly out. As an example, I'm not going to pick up on something like that. Now, as you learn this stuff, you kind of learn it in kind of like a very much an AO1 format, like explain. But some of the essays will say, is it physical factors that cause the disaster, or is it human? So you have to weigh these things up. You're not going to get deaths by volcano in an area where there's no volcano. So clearly physical factors do play a role. And remember, these do create very strong possibilities of a major eruption. You get that viscous magma and acidic very often, very sticky, tends to create explosive events, high magnitude events, but less often. Here we go, and you can see there's the Philippines. Something like 7,000 islands there, and you can see we've got this collision taking place, convergence. If you want to confuse it with a collision zone, and this is an island arc, effectively volcanic. And although it's tropical, it's beautiful, having spent many months there as myself. It's very mountainous. It's the coastal areas that tend to be flat, and you can see the two plates crashing together, and you get that subduction. Here's a picture we've used before. So in this instance, this is a theoretical picture, but it does really well for this purpose in this session. This ocean plate is colliding with this ocean plate, subduction takes place, slab pull happening, the Benioff zone, and then as we move down, the friction, and obviously it's going closer to the mantle, going in the mantle, it's the asthenosphere part, and we get this melting of the plate, that you get new magma form that rises up, breaks through the crust, and then erupts on the seafloor, and then over hundreds of thousands and millions of years creates islands, and they continue to erupt to form these volcanoes. So again, it's important that you learn that stuff. So Mount Pinatubo. So here we got just a few details here. So 91, Luzon, which is the big island, that's where the capital is as well. Luzon, I don't think it's that far away. It was dormant for 500 years. It's the second biggest volcanic eruption of the 20th century, apparently. There we go. I've talked about that before, just in the last slide. And here we've got some of the impacts that happen. The stratosphere is the layer of the atmosphere above the troposphere. The troposphere basically most of the observable weather. And the stratosphere, so it's above 12 kilometers. I think it goes up to about 40 50 kilometers. And if ash gets into that layer, it goes around the world quite quickly, relatively quickly. And therefore, things like sulfur dioxide, ash goes into the air, and then that has an impact on climate, what we call global cooling. So on the next few slides, what I've done, I'm not going to go through all the things here because you'll get the resource of this, and it's a case of like getting some of the information down. I've got 3 slides here. So effectively, I'm looking at the impacts. This summarizes some of it, and then in the next slide, I've got it divided into the different sorts of impacts, and then I've got the responses. Any deaths are really sad. They did know this was going to erupt. There were like lots of early signs. So they did evacuate huge numbers of people. Look at that figure there, right? Um, Death toll 800. So swings and roundabouts. And that death toll is high in some respects, but it could have been far, far worse. And then you can see, when you get ash, I think it goes over 11 centimeters of ash on a building causes a roof to collapse, gets in your lungs. And I think it turned day into night. And when it mixes with like they had monsoon rain, I'm not sure, maybe there was a typhoon linked in at some point. It creates this like really heavy, like sludge. Farmlands get covered, crops can't grow, engines of cars and planes have to, they get clogged up, you can't fly. So, it has a big impact. And here you can see a little bit more specifically. Look at that thing there. So that ash and sulfur dioxide going into the atmosphere lowered global temperatures by half a degree between 91 and 93. That's the sort of impact it can have. These sorts of things, I think, definitely learn. And it's, if you learn all of this, you could create probably a cracking response in an answer because there's actually quite a lot of volume there. You've got specifics about deaths, estimations of damage, the sorts of physical sort of impacts that created. On this slide, you can see some of the, the prediction element. There we go. There's the geological service, but I also think the military, the Air Force were involved. Look at that. I mean, that's just one of those things. Get people out there. Remember, a lot of volcanoes are in quite remote areas. So you might think, well, there's millions of people living in the cities that aren't stupidly far away. But actually, that's probably quite a lot of people, bearing in mind it's mostly a rural area. Alerts are put up, equipment, resources put into position where, they can set up like camps, food, water, all those sorts of things. On this slide, so this isn't a reference today, but I found a YouTube clip, it's about 10-15 minutes long. So if you want to look at a bit more depth and see the reality of that, then you can do that. That will be on the booklet or the PowerPoint version of this. You can click on that. And then this one here is kind of like how things evolve a little bit. So you can see it's very easy to say it's a fatalistic country and get this image that it's very poor and they didn't do anything. So in combination with the Americans, what's going on in their own government, you can see there's some quite sophisticated things going on there. But also remember, this was a huge volcanic eruption. You're quite limited what you can do once it's erupted. There's lots of things you can do before the volcano, like it's there, you can monitor it, you can evacuate people, you can strengthen the buildings, the roofs a little bit, have things in place so you can get people out of harm's way. But once it's erupted, there's very little you can do to mitigate it, as in you can't stop it, you can't put a giant plug in it, you can't drill into it to release the pressure. You might be able to redirect lava flows, etc., but it's all very limited. So on the back end of this is the second case. So there's actually quite a lot more depth here. So this would be more a case of you reading through this and getting more specifics. This is taken from one of the textbooks. Mount Mayon, this erupted in 2018, so 6 years ago. And again, it's got the same causation, I would say. I mean, you've got like slightly different plate boundary involved. You've got different facts and figures. This one didn't kill anyone, luckily enough. That always seems to disappoint some people in terms of interest level, which is always a bizarre sort of thing about the nature of us as people. We're kind of interested if there's lots of death and destruction. So Mount Mayon, if you're looking for something a bit more in depth, this provides this is on the PowerPoint and the PDF work document that I'll produce. And you can see if we look at this one here, we've got the when it happened, why it happened, some background about the actual volcano itself. And then if you look here, so this it's got nicely termed here, risk and vulnerability. So it says about people who are possibly in harm's way. There's something about the city, 200,000 people living there. And then it gives some information about the actual hazards, like there's potential for lahars, ash, etc., the damage that it can do to the property and people's businesses. There we go, our pyroclastic flow, which is always really scary. Remember, pyroclastic, remember, I said previously, doesn't tend to extend too far. If you're in it, it's not good. And remember we said about lava, for example, usually moves slow enough for people to get out of the way, but tends to maybe destroy buildings, cover crops, etc. On this section here, it just gives some background about the actual volcano itself, like the past, but specifics about the type of lava that's created, the events, and the hazards. On this bit here, we have a little bit of a diary extract going over a few days, so actually months. So what activity happened, and that runs down there. Yeah, and you have to be careful. I mean, trying to learn all that's just like a lot, isn't it? Where you think here is actually give some more specific like responses to that. And then subsequently, look at this one, like schools and colleges reopened, and then dropping the alert level. So showing that things are very sophisticated, and it's not just like, you know, a very basic response. And then this final bit here, we've got some more stuff on impact. And then we've got some of the responses. There's local and national response. And then we've got the international response over here. And some of you know, you can sometimes even use some of the multi-hazardous stuff. There's another case study that says at a local level. This might provide you that information, which might double up for that, but that's something that you have to decide for yourself. So I'm providing 2 case studies here, 2 volcanoes, only one of which you need. It covers the volcanic eruption, causes, impacts, and responses. Also tackles the multi-hazardous environment, so that's a partial bit like part of the jigsaw. You could box clever and use it for the local example as well. But in some of your schools, or if you know, you may well use other case studies like Montserrat, for example, Etna, Stromboli. What's the other one? There's one in Japan, Merapi, and there's one more I wanted to mention. You might use the Iceland volcano, which I always struggle to actually say what it is without sounding like a muppet. Okay, anyway, so that's that case study. So I've gone through that information. Obviously, you've got the PowerPoint you can use, the PDF, etc. Next lesson, what I'll do, the final chunk on volcanoes, and that's I'll look at the strategies, yeah, protection, preparation, prediction, mitigation, all those things. Okay, thank you for listening. See you next lesson.